We will continue with the cloud computing. So let us look at the data center and the cloud operating system or cloud OS. So why we need to look at data center and cloud OS? Because after we have understood the virtualization and how specifically CPU virtualization and memory virtualization, we need to move up a little bit, because what we learned so far is more at the real low level of the key issues of virtualization. And a data center essentially is made of a set of clusters, cluster of nodes on which the hypervisors are installed, and many virtual machines run on top of this hypervisor. And it is those VMs which are basically rented as a computing resource, and that basically forms the backbone of IaaS. And from IaaS, obviously, there is PaaS, and then SaaS. So which is why I'm saying that we are slowly moving up right from the virtualization. We need to understand, at least at a high level, what is a data center and what happens and what's meant by the cloud OS. So data centers essentially, as I said, must be virtualized because only then the resources in the data center can be shared, can be pooled, all the properties of cloud computing can be achieved. There are several softwares, open source and commercial, which are basically used to manage the data center infrastructure and basically provide VMs as a resource to the clients. Now, these open source as well as commercial infrastructure managers are tailored for virtualizing the data centers, which basically consists of a large number of servers, and those servers are actually formed. A cluster is formed out of those servers. There could be many clusters. Each cluster may have a set of servers, and a set of cluster forms a data center. So these open source as well as commercial infrastructure managers are there to manage these set of clusters. So the set of open source softwares are Eucalyptus and OpenStack, and commercials are VMware Rackspace are the two popular ones. So the role of these software is to basically create, manage VMs, aggregate the VMs into to actually form more of a virtual cluster. Then it provides a dashboard for management and control of the entire data center. Amazon EC2 is basically a good example of a web service through which this elastic computing facility is provided over the internet. And EC2 basically provides the customers to create their own VMs using a template, and this EC2 portal manages user accounts over time and basically monitor the use. Various cloud platforms now let us look at. So this is basically a table. This is for your reference. So let's look at the first one, which is the Nimbus project. And this Nimbus project basically uses Linux as a core operating system, and the resources that are being virtualized are essentially VM creation, virtual cluster creation, and this details can be found in www.nimbusproject.org. It uses EC2 compliant APIs as well as command line interface. The hypervisor that it uses is Xen or KVM, and public cloud interface is EC2. It also supports network virtualization. Eucalyptus is one more open source cloud manager So it uses Linux, and it uses the BSD license. It can be found in www.eucalyptus.com. Very similar to Nimbus, provides EC2 web services API. Zen and KVM is supported, and so it is compatible to EC2. Open Nebula is another similar software for VM management, same as it uses Linux, and it uses Apache v2 license. It supports management of VM, virtual networking and scheduling tools. It uses both KVM and Zen hypervisor. It is compatible to EC2. vSphere 4 is basically from VMware. It's a commercial product. It can be installed on top of Linux, Windows, or even bare metal, meaning that on the raw hardware. And this is the OS for data centers. Client API, it has its own client API. VMware ESX is a hypervisor that's used, and public cloud interface for vSphere would be VMware vCloud. OpenStack is another open source cloud manager. So it's on Linux, uses Apache v2 license, VM creation, storage management, the key management, which is a very important part in this case. These are all supported. In fact, vSphere 4 will also support key management. So it uses a hypervisor KVM, Zen, as well as it can work on VMware. It can be integrated with EC2. It can has a public cloud interface, which is EC2. Special features is it supports network usage, storage, as well as live migration. For VMware, it supports not just network virtualization, storage. It also provides high availability, disaster recovery management, as well as it can support very sophisticated live migration of VMs from one machine to another. Let's look at Eucalyptus in a bit more detail. So this is how the Eucalyptus software will work. So it has got a cluster manager CM, and and this is a public network, and these are the two clusters. These are all instances, or these are all, you can think that these are all basically hardwares and instance managers. There is a private network through which these machines interact, and there is a group manager, and the cluster manager would be interacting with this group manager. This is how it looks like. So instance manager essentially controls the execution, inspection, as well as a termination of different VM instances. This group manager essentially gathers information from individual IM, as well as it is responsible for scheduling VM execution on a specific instance manager. So it's basically manages a cluster. GM is essentially a manager for a cluster. The cloud manager, or the cluster manager, it's also called cluster manager, a cloud manager. This is basically the entry point into the cloud for the users and administrators. It queries a node manager for various information about the resource usage, makes different scheduling decisions, as well as it implements them by making various resources, various requests to group managers. So what Cloud Manager does is, Cloud Manager is a front end. It receives requests from users. Based on that, it contacts the group managers for actual provisioning of a resource. So essentially it instructs the GM to provide a resource which is virtual machine, and then GM in turn interacts with the instance manager to create the VM. So Eucalyptus essentially provides a storage mechanism, storage API that actually emulates Amazon S3, and Eucalyptus is compatible to EC2. So S3 API is used for storing user data as well as VM images, and you can basically create a Eucalyptus based cluster on Linux based platforms. Let's look at one more such cloud manager, OpenStack. So OpenStack actually has different components: the network component, compute module, network module, VM storage, object storage, and there is a block storage, and there is a dashboard through which one can interact with these components. This is a identity manager where the keys are actually stored. So the compute module called Nova, it manages the resource allocation and life cycle of different virtual machines. The network module, which is this one called Neutron, provides network connectivity between different devices, different VMs. It basically provides API driven networking, and it also helps in managing the IP addresses for the VMs. So essentially for each VM, the private IPs that are created, this network management module, Neutron, essentially decides the IP addresses, and it also provides the administrator some view of the different types of networks that are allocated, different type of IP addresses that are allocated to the VMs, and it also helps the administrator to basically manage the network. Storage is storage manager is essentially called Swift. It allows the data to be stored and retrieved as objects. Now this particular VM image, so here the VM images are actually stored, which are from this. The compute module essentially takes the VM image and instantiates it, and the persistent block storage of data to the VMs are essentially kept here. So essentially these block storage, object storage, and VM manage image, these are the three components which are responsible for, number one, managing different types of VM images. Because if you are familiar with Amazon EC2, you will see that there are different types of VM templates, like small, medium, large, and with pre-installed operating systems. So a VM image essentially would be managing that, and when you instantiate a VM image with some associated hard disk, virtual disk actually, so the data that is stored, that is created and stored alongside with the VM, that data will be stored in this block storage here. So for that purpose, this block storage and VM image, they would be interacting with each other, and this object storage would be used for checkpointing purpose. Now this identity manager is called Keystone. It basically provides authentication, authorization, access control for all interaction between different services. All of these modules are implemented as services, exactly same as the way you find it in EC2. These are all can be managed through programs. If you are familiar with EC2, we will know that in the command line interface, or in Java or Python interface, it actually through programs you can basically create VMs, attach block storages, define network, define clusters. So for all this, since these are all in that sense a service, because as I said, that you can basically programmatically create the whole thing, create an VM, create block storages, create network. You can create that through programs. and what that means is that there are well-defined APIs using which you can do all this. Those APIs are nothing but basically services. So each time a service request is sent to either this module or this module or this module, the OpenStack needs to authenticate and authorize. So for that purpose, it needs this key value pairs. So identity management module essentially manages those keys and validates a particular service request. This dashboard is called Horizon. Now, as an administrator, you are supposed to look at this dashboard and then basically manage the web stack services. This is, again, this kind of mimics EC2 portal, where there is a EC2 dashboard and behind this, and this is the dashboard through which a user would be creating and managing different resources. So the dashboard essentially can assign physical resources like CPU, RAM, etc. to an image, and different types of images and snapshots are possible. Linux, Windows, and AWS EC2 images. Different types of containers are allowed. Single container in which the VM would be stored of different types, and it provides the VM lifecycle management like terminate an instance, reboot, log actions in an instance, create a snapshot for checkpointing. So this is what the OpenStack basically provides. Now, I very briefly talked about the cloud manager, and this is what I call it as Cloud OS, which, so essentially that software like OpenStack, then OpenNebula or VMware's proprietary softwares, those are all required to convert a data center into a cloud-based service. Like if you want to offer an IaaS kind of service, you would need those software on top of the data center, which is why that's also called a cloud operating system, Cloud OS. So let's move on to the cloud architecture now and understand the public and private cloud in a bit more detailed manner. So the private and public clouds are essentially two commonly used cloud platforms. Of course, there is the third one which is emerging, which is called a hybrid cloud, which is in between public and private. So public cloud is essentially owned by service providers, and private cloud is typically created inside an organization. It basically leverages the existing IT infrastructure, so it's restricted to the users who are within the organization. Creation and management of VM instances within the proprietary infrastructure. So essentially what public cloud does is that it creates and manages VM within its own proprietary infrastructure, but because it is public, so the users are going to use these services in a more standardized manner. So by standardized manner, what I mean is that if this public cloud is essentially publicly available to different clients, all the clients would be using the VMs in the same manner. And if that particular public cloud provider becomes popular in a sense, then essentially many clients would be using the same type of mechanism to access the resources, and that makes the whole interaction a kind of a standardized. So it preserves obviously capital investment and provides application flexibility. That's also true for public cloud. That's also true for private clouds, sorry. But the difference is that in the private cloud, this infrastructure is client managed, and therefore one advantage over the public cloud is that the client can basically customize it in their own way to get a higher efficiency. So in terms of workload distribution, this workload is handled without any communication dependency. It distributes the data and VM resources, and it manages the workload surge well. However, in the private clouds, this workload handling, though it is handled dynamically, but workload management, in fact what happens is, in the private cloud, the workloads are better balanced compared to a public cloud. The reason is that in the case of private cloud, because it is tightly controlled and basically with foreign organization, so the organization actually knows the kind of workload that it's going to experience. Therefore, the decisions that it can take to balance the workload across different servers would be definitely much better than a public cloud, because the public cloud provider is really not aware of such workload details, because it is completely public and there are many people who can come and go. Therefore, it is not easy to guess the possible workload that can come onto their data center. Public cloud is basically accessible through remote interface, and so in that sense it is more open. In the case of private cloud, it is completely controlled, tightly controlled. Access is really limited within the organization. Examples of public cloud would be that Google App Engine, Amazon AWS, Microsoft Azure, and the example of private cloud would be IBM offering RC2. So IBM and many other IT services companies would essentially be going to the large corporates and basically would offer a private cloud solution to them. So let's look at infrastructure as a service in a bit more detailed manner. Amazon EC2, Rackspace, and so on, they offer computers as physical, more often as VMs and other resources. So VMs run on a hypervisor such as Xen or KVM, and you as a client, you as an end customer, basically buy a VM of certain capacity, often with a pre-installed operating system, and then you install your own application software and log in to that VM via SSH or through a browser. So Amazon, Rackspace, and many other such IaaS providers will bill you as per the number of hours the VM is running. That basically reflects the amount of resources allocated or consumed. Amazon CloudFormation is basically another service that you can find if you go to Amazon EC2 portal. So this Amazon CloudFormation essentially provides such insights. There are other examples like Rackspace Cloud, Terramark, Google Compute Engine. They also kind of provide a similar kind of insights. Let's look at the platform as a service and software as a service. So Microsoft Azure, Force.com, etc., they deliver a computing platform as opposed to a raw VM. So that includes operating system, programming language, execution environment, database, web servers, etc. You can develop and run your software on this platform. So here you don't have any cost of buying the software or managing them. In fact, managing even the underlying hardware software layers. So you just use it and then you get billed for that usage. Example would be Amazon's Elastic Beanstalk, Cloud Foundry, Heroku, Force.com, Mendix, Google App Engine, and so on. These are all examples of platform as a service. But there are software as a service also, like Salesforce.com, which will give you a ready-made solution for CRM that is typically one level higher than, in terms of abstraction, one level higher than platform as a service. So you access the software. For example, Microsoft would give you Office 365, Word, Excel, etc. through browser-based environment. Pricing model is typically monthly or yearly fees per user. Google App Engine, then InKeepOS, QuickBooks Online, etc. They all provide such software as a service. So in terms of the pricing model, the IaaS basically prices you based on the hardware usage. If you just take the VM but don't use it, but keep it live, you will be charged. Whereas for platform as a service, if you don't use it, you will not be charged. You'll be charged only when you are using the software or the platform. So side by side, IaaS, which is on your left here, these are VMs, and there are a cluster of VMs which are on different machines, and this is a provisioning service. Simple database, simple DB, simple queues, S3 simple storage. This is what makes it Amazon Cloud. On the right hand side, the platform as a service. This is a Google Cloud. This application deployment and distributed execution platform is here. So what I am trying to show here is that on the left you could see all the VMs, but on the right you have no idea of the VMs. You basically get the platform. On what VM it is running, you have got no idea. Then there is Google Data Store, which is basically like this, and then there are MapReduce and Bigtables which are there. And of course there is a development SDK through which you can access this Google Cloud. In IaaS, Amazon Web Service, AWS, is the leader. So let's understand EC2 in a bit more detail. EC2 is called Elastic Compute Cloud. It allows to rent VM, add more VMs on demand. You can create, launch, and terminate server instances as needed by paying the hourly, by the hour for the active servers. S3, which is a simple storage service, basically provides a object-oriented storage service for the users. Elastic Block Service, EBS, basically provides a block storage mechanism which can be used to support traditional applications. Essentially, when you create a VM, you can add different volumes from this EBS by paying extra. So when you get EC2, you get some default storage. Maybe say you get some 50 GB of hard disk. You can add another 100 GB of hard disk as an additional volume, and that will be attached with your EC2 instance, and that additional volume will come from EBS. Amazon DevPay is a simple online billing software and account management service that makes it easy for different businesses. MPI clusters basically use hardware assisted virtualization instead of para virtualization, and users are free to create new AMIs if you use MPI facility of Amazon. AWS essentially allows import and export mechanism by which large volumes of data to and from EC2 can be imported or exported through shipping the physical disks. This is basically, this kind of services are typically offered to the small businesses or medium businesses who want to basically start their web-based systems on top of AWS. Example being that let us say Netflix. So Netflix is completely based on EC2. New York Times also based on EC2. So their entire content, their software portals, they're all run on EC2. So for such kind of business houses, AWS import export, bulk import export facility will be provided, where they can ship physical disks, and those data will be uploaded. So as I said, small business companies can put their business on the Amazon cloud platform. Using AWS, they can actually service a large number of internet users, and they can make profit through those paid services. Essentially, for the small business companies, it makes sense to rent the infrastructure as opposed to just install it on their own, and therefore they kind of reduce their capital expenditure. And for Amazon, of course, it's a very good business, because they are also able to utilize their services, their servers, and that's also a very good kind of business model for Amazon as well. So for the small business companies, what they sell is maybe software as a service to the end client, and what Amazon does is Amazon sells infrastructure as a service to the small business companies. So the VM access, so what happens is that you can use a web services based interface to launch instances with a variety of operating systems which are bundled into AMI, load the VM with a custom management environment, and then manage network access permissions. It scales really fast. You can obtain and boot new server instances real quick. You can increase or decrease the capacity. On-demand instances is pay by hour, as I said, start and stop as you wish. You can instance a reserve, pay by the year. So if you reserve the instance, that can be stopped or started as needed. So one important thing is that there is something called a spot instance. So this spot instance price is certainly less than the regular instances, but the spot instance happens through bidding. So what Amazon does is unused EC2 capacity is kept open for bidding, and there are some spot prices. So by paying the spot price, you can get a spot instance. So if the market price is less than the spot price, then you will get your instance. However, when the market price goes up and it becomes more than the spot price is the price that you have bid for, and then you got it. So when the market prices go up, and then when it exceeds the spot price, your instance will be terminated. Let's look at the Amazon VM lifecycle. So when there is a request to run an instance, EC2 run instances, then Amazon VM goes into a pending state. Then from there it becomes running, then it goes into a running state. It takes some time to become a running state, and if from the running state, if EC2 is rebooted, it again becomes into running state. From running, it can be stopped. It comes to stopped state. From stopped state, it can again go back to running state. Or from running state, it can be completely you can completely shut down the VM. So it's called terminate instance. So here from running, you can send a command called EC2 stop instance. Then from the stop instance, you can say EC2 start instance. From running, you can say EC2 terminate instance. It becomes shutting down state, and then it gets eventually terminated after some time. So these states are from here to here. It happens. It's time based. It takes some time to come to this state. From here to here again, it takes some time to go to this terminated state. From here to here, it can happen through this command called EC2 terminate instances. Again, it takes some time, and then after that, it becomes terminated state. So remember that once it is terminated, the data is lost. This orange color border is essentially means it's EBS backed EC2 instance. So data persists as long as the EBS volume is actually intact. When EBS volume is gone, data is also gone. Now, as I said, that Amazon Elastic Block Store EBS offers persistent storage for Amazon EC2 instances, and it persists the image file independently from the life of the instance, which is why I'm showing it like this. So this particular box, which is in green color, this indicates that this is the scope of the VM. As I said earlier, the VM contains VM instance might contain some storage associated with it, plus it can have an additional EBS. So even when a VM is bundled with a default data, that also comes from EBS. In any case, there is a VM and there is a data storage which is in EBS. So VM images are here. So VM images definitely persisted for checkpointing and recovery, and the data is persisted completely separately. So you can basically create a point-in-time consistent snapshot for your volumes. You can say that you want to snapshot your image as well as snapshot the data volume. So this can be used as a starting point for new Amazon EBS volumes. If you create a snapshot of it, and then later on, if you want to create a new VM, you can say that create a new VM, but use the old snapshot. So what that means is that you can create a completely new in a virtual machine, but you can start using the data. Therefore, it can protect the data for long-term durability. It can be, in fact, these snapshots can be shared with co-workers or other AWS developers. That's a very important part. Another important part is that the cost. So here the cost of a VM is based on instance hour. Here the cost is based on EBS volume. For the data, it is based on the EBS volume. Here the cost is based on the instance hour. So when it is running, then there are two costs. One is this instance hour cost, and another is the EBS volume cost. From running, when it comes to a stopped state, then you don't have to pay for this running cost, which is instance hour, but you have to still pay for the EBS volume, which is why I have showed that in the orange boundary. You have to still pay the EBS volume charge. But from the stopped state, when you say shut down or terminate, when it comes out of this, then you don't have to pay this as well as this. So remember that when it is running or rebooting, you have to pay both. When it is stopped, you don't have to pay for the instance hour, but you have to pay for EBS volume. But when you terminate, you don't have to pay anything. These snapshots are essentially stored in the object storage, which is S3, and they're automatically replicated across multiple availability zones. So with this, we stop here, and this basically gives you an overview of cloud computing and how IaaS is actually live in action through the example of Amazon. So in the next class, we will now talk about what is a software architect's role in the context of cloud-based systems. Thank you.